Hello everyone, I am Ayush Pansali and this is my journey of making a 5 degree of freedom robotic arm. So sit back and enjoy. This was the first time I worked with 3D printed parts and a microcontroller other than Arduino, which is STM32. It's more like a microcomputer, being more than 5 times powerful than Arduino in almost the same form factor. And this complete arm was built under 72 hours. So here is the complete build. Most of my projects are either mechanically intensive like the all-terrain robot, war robot, hovercraft, etc. or electronics and coding intensive like the line follower robot or the RC car. But this was certainly an exception and perhaps the most difficult project till now. After building the structure of the arm, I moved on to making the controller. Then I moved on to testing the electronics individually. Then I started to solder all the components. soldering the main PCB, I started to connect the controller and the arm to STM32. After this was hours and hours and hours of coding and debugging. And finally, here is the robotic arm. For the movement, the arm uses 5 servo motors and 1 for the gripper. And here is the main circuit. As STM32 is a 3.3 voltage based controller, so this is a voltage regulator based on LM317. Also, the STM32 can only provide 6 mA per pin. So to control LEDs and buzzer, these transistors are also used. There is a Bluetooth module to control the arm wirelessly and an FTDI breakout for debugging. And here is the brain of the system, the STM32F103C6T8, also called as the blue pill, other power LEDs, and an OLED display to show the current coordinates. This system is powered by a 5V 10A power supply. To control the arm, it uses hand gestures recorded by an accelerometer. The main button coupled with the hand gesture control the movement of the body, that is the shoulder and the elbow. To control the hip joint and the gripper, it uses potentiometer and 2 switches to open and close the gripper. So here is the arm in action. It can move forward, backward, up and down. Now to control the pitch of the elbow, I have an auxiliary switch. This was the main switch, which controls the front, back and up and down movement, basically controlling these 2 big motors. Now for the pitch, and the hip motion, which is the rotation of the arm, is controlled by this dial, and opening and closing of the gripper is controlled by these 2 switches. To have this straight line control of the arm, it uses a technique called as Inverse Kinematics. In simpler terms, it uses trigonometry, calculus and matrix to compute the appropriate angles for the shoulder and elbow joint. Here is the code snippet if anyone is interested. All the movement can be coded as well to perform any action repeatedly. And that is how the robot made a cake for me. Now enough of the technical stuff, let's see the arm in action. Thank you everyone for watching.